Hello everyone, my name is Gisler, and in the next 15 minutes I will present to you our submission for the Cyberworlds 2020 conference with the title Designing Virtual Training Environments, Does Immersion Increase Task Performance? I will commence my presentation with a short introduction. I will then give you a brief overview over the related work and our chosen use case. After that, I will guide you through our user study, present its results, and discuss them. Finally, I will end my presentation with a crispy conclusion and an outlook to future work. The ability to create a comprehensive illusion of reality makes VR a promising technology, especially for training and education. The advantages of using such a virtual training environment have become abundantly clear in the past. Namely, they are cost efficiency, measurability, repeatability, scalability in content as well as user accessibility, and safety. Now, although virtual training environments have existed for decades, there is still an ongoing controversy regarding their design and success. One of the main concerns of research on virtual training environments is the comparison to traditional training such as real training or other media. When we looked at previous studies that addressed this concern, we saw that the findings vary greatly. For example, a study by Ho and colleagues found that virtual training is better than traditional training. On the other hand, a study by Makransky and colleagues found that virtual training is worse than traditional training. And the third study by Rose and colleagues yielded that virtual training is comparable to traditional training. Now, how does all of this make sense? First of all, it is important to note that all of these training environments concern sensory motor tasks. However, upon closer investigation, we found that these training environments varied substantially in their immersive features. Therefore, we concluded that a better understanding of the concept of immersion is needed to explain the discrepancies in prior research. Having delineated the research gap we want to address with our study, let me now introduce you to our use case. We chose the assembly of a modular support system as a use case for our study because it is a task that is carried out on a daily basis throughout the world. Modular support systems, such as the one you can see on the slide, are used to mount water pipes, gas pipes, cable trays, or ventilation ducts to ceilings and hallways. The specific modular support system we chose for our study consists of angular conjunctions, two different types of rails, and a so-called push button. A push button is a load-bearing connector that facilitates assembly. However, its working principle is supposedly not self-evident. Consequently, the task that was to be learned in our virtual training environment is the assembly of a modular support system. In order to do this, participants need to understand three core concepts. First, they need to be able to distinguish the different types of rails. Second, they need to be able to identify the rails orientations on a 2D layout. And last but not least, they must understand the working principle of the push button. Then, and only then, they will be able to correctly and completely assemble the modular support system. Let me now continue with the study procedure. The study procedure consists of 5 distinct phases. In phase 1, 3, and 5, we ask the participants to answer questionnaires to obtain subjective data on their well-being and their perceptions of the virtual training environment. These questionnaires include common questions on demographics, simulator sickness, and perceived task load. In phases 2 and 4, the use case of the study is directly addressed. Phase 2 is conducted in virtual reality, while phase 4 is done in a real environment. Furthermore, we chose a controlled between subject study design with 2 experimental conditions and 1 control group. The difference between the 3 groups manifests itself in phase 2. While participants in the control group play an unrelated VR game, participants in condition A and B learn to assemble the modular support system in a virtual training environments. The virtual training environments that we developed and implemented for this purpose differ in immersion, but are otherwise identical. The control group was included to detect a possibly occurring ceiling effect originating from the misjudgment of the evaluation task's difficulty. In case the evaluation task was too trivial, a training of any kind would be obsolete, since participants could just fulfill the task without any prior instructions. Now let us take a look at the immersive features that make up this difference in immersion. Before elaborating on the differences in immersive features, let me give you some background information on our technical setup. For our study, we used an HTC Vive Pro system, including its 2 controllers and 4 tracking stations, spanning a walkable area of 8 by 8 meters. The training environments were implemented in Unity. So, considering state-of-the-art VR applications, the development of virtual content is much more expensive than the hardware. Furthermore, we wanted to investigate on instructional features that could be supported by a system rather than just comparing technologies. Therefore, we focused only on software-related immersive features and left the hardware-related features as they are provided by the HTC Vive Pro. In the low-immersion virtual training environment, the mapping of users' actions into actions in the virtual training environment were abstract. The interactivity was low, and neither acoustic nor haptic feedback was provided, and there was no virtual body. On the other hand, in a high-immersion virtual training environment, the mapping of users' movements into actions in the virtual training environment was much more natural. The interactivity was higher, users got acoustic feedback, vibrotactile feedback, and a virtual representation of their body. More explicitly, their hands were shown. For those viewers that are not too familiar with the concept of immersion and especially immersive features, the table in the previous slide might have been confusing. So in order to further clarify the differences between the 2 virtual training environments, let me now show you some images and videos. On the left-hand side, you see a photo of the participants in the low immersion training, and on the right-hand side, you see a photo of a participant in a high immersion training. Participants in the low immersion training environment were sitting on the chair throughout their whole training sessions, whereas participants in the high immersion training environment could walk around freely. Furthermore, participants in the low immersion training environment could only interact with the virtual training environment by pushing buttons on the controller. On the other hand, in a high immersion training environment, participants could interact with virtual objects by actually grabbing them and moving them to their target locations as they would in reality. Last but not least, in the high immersion training environments, participants also received audio cues indicating their progress in the virtual training. On this slide, you see a side-by-side comparison of the same phase of the training in the 2 virtual training environments. On the left-hand side, the video of the low immersion training, this part starts moving by itself simply after the user presses a button on the controller. On the other hand, in the right-hand side, the video of the high immersion training environment, the user has to actually grab the part and move it to the right location in order to proceed. This slide shows another side-by-side comparison of the same phase of the training in the 2 virtual training environments. In the low immersion training, an animation starts simply by the press of a button on the controller. On the other hand, in the high immersion training, the interaction is again much more natural. Participants had to grab the correct part and execute the corresponding action in order to proceed with the training. I hope that these examples were sufficient to give you an idea of the differences between the high and the low immersion training environment. The content of phase 2 of a study session should now be sufficiently clear. And since most of you will know what a questionnaire is, let me now jump straight to phase 4, the real-world evaluation task. In phase 4, we evaluated the training success of the participants. The explanation of this real-world evaluation task is straightforward. Participants were given 15 minutes and asked to take the parts shown in the left-hand image and use them to assemble the modular support system on the right-hand image. For this, They were also given a 2D layout of the modular support system they were asked to build. Attentive viewers might have already noticed that we provided more parts than are actually required. This was done in order to confuse participants that did not sufficiently pay attention in the training. So by now, I'm sure you are eager to hear about our results. Don't worry, you won't have to wait any longer. For this pilot study, we recruited 30 participants and randomly assigned them to one of the three groups. Fortunately, none of the participants experienced peculiar symptoms of simulator sickness, and thus none was excluded. For the sake of concisiveness, I will focus on the most interesting results for this presentation. To see all our results, please have a look at our paper. On average, the self-reported physical demand in the high immersion virtual training environment was 175% higher than in the low immersion virtual training environment, while mental demand was fairly similar. And with an average of 35 out of a possible 100, the mental demand in the evaluation task was lowest for participants trained in a high immersion virtual training environment. This indicates that participants being trained in a high immersion virtual training environment were able to transfer their acquired knowledge more efficiently than the participants from the other two groups. However, none of the observed differences in the TLX score exhibited statistical significance in a one-tailed t-test. Besides TLX scores, we also measured completion rate. We defined the completion rate as the share of participants in each group that was able to completely assemble the modular support system in a given time. The fact that none of the participants in the control group was able to complete the assembly indicates that the difficulty of the chosen use case was adequate for the intended purpose. Furthermore, a comparison of the completion rate shows that participants trained in a high immersion virtual training environment were 3 times as likely to complete the assembly as participants trained in the low immersion training environment. And since the virtual training environments were identical apart from their immersion, this indicates that immersion does increase task performance. However, the sample size of our pilot study is too small to draw any meaningful conclusions. So, let's get to the crispy conclusion. A review of the related work revealed that studies comparing virtual training to traditional training yielded varying or even contradictory results. Upon closer investigation, we found that the virtual training environments used in this study differ greatly in their immersion. We therefore suspected that immersion might affect task performance. We then set out to test our assumption in a user study. The user study consisted of 5 phases, and we choose a controlled between-subject design. Furthermore, the evaluation of the task performance was done in a real-world setting. Our results, especially the differences in completion rate between the low immersion and the high immersion training group, indicate that immersion does indeed affect task performance. However, the sample size of our pilot study is too small to draw any meaningful conclusions. This leads me straight to the outlook. For future work, first and foremost, the observed tendency needs to be extended and further investigated. Identifying a relationship between immersion and task performance will result in the next major step for training in VR, since immersion would become a valid option to qualitatively estimate the effectiveness of a virtual training environment. And by further investigating the immersive features, a finer granulation shall be created and evaluated. Based on this, the optimal immersion should become identifiable. In the planned extension of our user study, we aim to increase the sample size and introduce additional objective and subjective measures such as gaze tracking, general motion trajectories, and also relevant user traits such as personal innovativeness. Finally, by upgrading the current system with physiological measurement devices, the training environment will be enabled to measure user stress and boredom levels by introducing new challenges and tasks. For those of you that are interested in the studies that were mentioned in the related works, here are the full references. With this, I conclude my presentation and thank you very much for your attention. If you have any questions, please don't hesitate to contact me by email.